Hello, welcome to week 5, Math 300 Tidbits. In this video, I'm going to do an example very similar to your assignment for this week. And it starts with having a table. So we've got the number of beds and then the annual patient visits. And in this video, I'm going to basically do everything that you're going to have to do on your assignment. I'm going to create a scatter plot of the data, which includes the regression line equation in R2. I'm going to calculate and interpret the correlation coefficient R. What does it say about this relationship? And I'm also going to identify any lurking variables, predict the response variable for a facility with 220 beds. And by the way, should be R squared. I'm sorry about that. I started to read it just across, but it's definitely R squared, which is our coefficient of determination. Okay, so here's what I'm going to do. I'm going to go into Desmos graphing, and I'm going to go ahead and put these values into my Desmos, just like Professor Keller did. So I'm going to click on the plus key and then table, and then I'm just going to type in the data that I have. So I have my numbers. Of course, my left column will be my X values, and my right column will be my Y values, which would be the number of patient visits in this particular example. And so I'm just going to type all of these in. And then from here, I can't see my graph because of my window, right? So I want to click on the zoom plus zoom fit here, which will actually fit the data for me. And so then I can see my graph better. And then from here, we want to do our linear regression. Now remember, if I put y equals mx plus b, then it's not going to work. I want to use that. Really, I think of it as an approximation, but it's called a tilde symbol. So I'm going to do y1, and I just type in y1, and it knows what I'm referring to. And then I do, for me, it's shift tilde, which on my keyboard, it's above tab for me. And then I type in m, which represents slope, and then x1, which represents the x1 value on my table, and then plus b. If you remember, y equals mx plus b is the slope-intercept form of a line. And so that's where I'm getting this here. And that should work for you as well. Now, what's really cool is it gives me the slope, which is 40.15045. It gives me the y-intercept, which is 679.83952. So when I create my regression line, I'll basically be plugging in the 40.15045 in for m. And then in for b, I will be plugging in the 679.83952. And that is going to give me my line. I also have, of course, my coefficient of determination, and my correlation coefficient is also calculated, which is wonderful. Thank you, Desmos. That's amazing. And then what I'm going to do is I actually used my snipping tool to save this. And I'm going to show you what that looks like in a minute. So I just clicked on my snipping tool, and then I was able to kind of save this whole thing at once. And then I was able to just copy it, right click and save the image. But you can save it however you would like to save it. Okay, so now what I'm going to do is I'm going to go into my iPad, and I want to show you the other part of the assignment. So I'm going to go a little farther, and I'm going to kind of like pretend that I'm doing the example or the assignment in a sense. So you'll have, of course, your assignment is very similar, but you'll have, of course, it'll be a little different. Okay, so from here is my scatter plot and my information. I've got the picture of it, but I do wanted to talk to you about R. So in this case, for my particular example, R is equal to 0.952. That is considered strong and positive and linear. But I want to talk about R for just a minute. So the correlation coefficient is a very important number. It can range from -1 to +1. The closer it is to, let's say, +1, that just means that it would be considered a positive, in this case, perfect linear relation. So if it's exactly a 1, that means that it's perfect. All right, so that would be really basically like a perfect fit. And we would also say that it is strong and positive. And then if you look over here to the left, right here on this graph, that is also perfect, which I did this on purpose. And in this case, R would be equal to -1. But notice that the line is going down. So this would still be, this would be considered perfect. It would be a negative strong. So it'd be a strong negative linear relationship. All right. So if it's -1, it is perfect. It's just a negative linear correlation. If it is R is equal to 1, it's also perfect, but it's positive. Now, if I have something that looks like this one here, and if I try to draw a line through my scatter plot, it's looking pretty good. Like, it doesn't have to be perfect. This could be like R is approximately like maybe 0.92 or so. That would still be considered positive, and I would say it's still pretty strong, right? It would still be considered positive and strong. I like to tell my students, think of it like as your grade in a class. If you got a 99, that's almost a perfect score, but a 92 is still pretty good. But if you get like a 50, that's not good. And so this one right here, I would say R is approximately like 0.02 or something, where it's just closer to 0. And there is no way for me to draw a line through this. The data is scattered. And so in this case, that would be considered weak, a weak correlation. So the closer it is to 1, the more perfect it is. The closer it is to -1, the more perfect it is. It would just be considered negative. And then the closer it is to 0, then the data is more spread out, and we can't like really say that it's a good indication of a linear regression as far as if it's strong or weak. Okay, so in our case, we have a 0.952, right? So that is kind of answering the first, well, I guess the second question, because the first question was to make the scatter plot. So calculate and interpret the correlation coefficient R. What does it say about the relationship? Well, in my case, R is equal to 0.952. This is close to 1. This implies a strong positive linear relationship. All right. And for your assignment, you're going to have to kind of figure out what R is and decide if you think like what kind of relationship it has. And then identify any lurking variables. So in this case, the information that we were given was the number of beds and then the annual patient visits based on, like the number of beds. Is there a correlation between the number of beds and how many people visit? And so some lurking variables could be that maybe the type of hospital matters. Maybe it's a private versus a public. Possibly the hospital location could matter, such as geographic region. Is it in a populous city, or is it more somewhere that doesn't have as many people? And so that could definitely be like considered lurking variables in this situation. And then it says predict the response variable for a facility with 220 beds. Is this a reasonable estimate? Why or why not? Well, what we'll do is we're going to take our linear regression equation, and in this case, that is where I'm going to, I took my M, right? We get these numbers from our Desmos, and I have my B, and I can actually create this equation, right? Where Y is equal to 40.15045x plus 679.83952. That would be considered my linear regression equation. And I can make predictions based off of this. So if we have a facility that has 220 beds, we can actually predict how many inpatient visits they will have. And I would say that this is going to be a pretty strong prediction, a pretty reasonable estimate, because of the fact that our correlation was so strong. All right, so now I'm going to actually use my calculator to calculate this for us. And so when I type this in, and what I'll do is I'll go to my Desmos scientific calculator, which I love, and I'm going to type in this expression. So I have 40.15045, and then parentheses, the X value, which in this case, we're trying to predict for 220 beds, and then plus, of course, the B value, which was 679.83952. We get approximately 9,512.9382 inpatient visits is what that would be finding. And so I don't know if did I write that on here? Okay, let me write it. Okay, so we get approximately, so when we plug that in, we got approximately 9,512.9 inpatient visits. And, we might round that up to 9,513 if you wanted to. But that is similar to what you're going to see on your assignment. And keeping in mind that the X value is the number of beds, and then the Y1 value is the annual patient visit. So if the number of beds was 220, and to our calculations based on our linear regression, we would say about 9,500, and I'll round up to 13. Would you say that that's a reasonable estimate? I would say yes, for several reasons. If you're looking at the numbers, it looks pretty good, like it's a reasonable estimate, but also our correlation is strong. And so that means that we can make these predictions. And so I would say it is a reasonable estimate in this case. All right, I hope this video helps you, and I hope you have a great day. Bye.